The third example is in vertex form. Remember, the vertex form tells us the x value and the y value of the vertex, and inside parentheses is opposite of what you see. So when I look at this one, I should see that the vertex is going to be at positive 3, 7. Positive 3, 7. But to verify that, I can go to my calculator, go back into the y equals screen, and then type in this equation that says negative 2 parentheses x minus 3 close parentheses, and that thing gets squared, and then plus 7. So let's see what that one looks like. Alright, we can see there that this one opens down and it has a maximum value here. So we do second calc option 4 this time is maximum. And we're going to scroll over so we're on the left side of the vertex, hit enter, scroll until we're onto the right side of the vertex, hit enter, have the calculator guess, and it does say we're at 3, 7. So then I'm going to go over to my table. I'm going to look around the value 3. So here's my vertex at 3, 7. And so the other points in my table are 2, 5, 1, negative 1, 4, 5, and 5, negative 1. I don't see x-intercepts here. I don't see any y values for being 0. So we're going to have to either calculate those by hand, or I suggest we'll just use the calc function. So we go second calc, and we want option 2, 0. Right, let's find the left one first. So we scroll to the left side of that x-intercept and hit enter. Scroll to the right side of it and hit enter. Have the calculator guess, and it says it's at 1.129. And then we go to the other one, second calc, option 2. Scroll over so that we're on the left side, so I'm on the left side of my x-intercept now, and then I scroll over until I'm on the right side of it and hit enter. Have the calculator, have it guess, and it says it's 4.87. So we can come back into our notes and say, okay, we have those x-intercepts, and then we have a y-intercept, and we can set y equal to 0 and solve for negative 11, or we could look at the table and find out when x is 0, we see that y is negative 11. This graph opens down. We already said we had a vertex of 3, 7. We took the points from the calculator, plugged them in here, and then we can take that information, put it onto our graph, and graph it. All right, the last bit of this is some problem solving. So the directions for this would be solve this quadratic equation. So for me, what I can do is I can take my calculator. We can go into our y equals screen, and anything on the left side of the equal sign, which was 13 minus x, goes in y1, and anything on the right side of the equal sign goes into y2. So we had 3x squared plus 4x minus 4. All right, let's graph and see what that looks like. Oh no, I don't see anything. So what we need to do is we can see our intersections are going to be up here somewhere. So I want to go into my table, and I want to look and see what are the values of this thing. So it looks like it's going to cross somewhere in around negative 3 and somewhere around 1 or 2. So the y values here, maybe they go up to about 20 or so, and the x values looks like it's going to be between negative 5 and positive 5 will certainly be enough. So I'll go into my window, and we're going to change these values -5 to 5. The x scale is 1. For the y's, it really, I don't need to see much, but I need to make sure that I can see high enough on my screen to get those intersections. So change the window to that. Now if I graph, I should be able to see the intersections there. In this case, I don't care about the vertex. The only thing I care about is the x value where these two graphs are crossing each other. So we do second calc, and this time we want option 5 is the intersect, so option 5. And then we can scroll along our line until we get close to the intersection, and we hit enter, and then you can adjust it if you want and make it closer for that one, and hit enter, and then enter again. And it says our intersection is at when x is 1.689. So the only part we need is the x, because our equation that we had only had an x, it didn't have a y. Then we go back to the other one, and we say second calc option 5 for intersection, and we scroll over to the other intersection. It takes a little second. And I don't have to get right on it. I just have to get close, right? So that's close. Hit enter, enter, enter. And then this one is at -3.355. So those are the two x values that make this work. So we had our window we set, and then we have our graph that looks like that, and then we had the two x values. So those are our two answers for x that make this statement true. Right, the one last one, word problem. And Tony stands on a balcony and throws a ball to his dog who is on ground level. Right, the ball's height is in meters above the ground. X represents the number of seconds that the ball is in the air. So, and then they give us an equation. And it says, what is the height of the ball at the time that it was thrown? What's the maximum height of the ball? And when will the ball hit the ground? So first thing is we need to take this information and plug it into our graph and see what it looks like. So we go back to y equals. We can clear out those. Right, and then our equation was a -2 x squared plus 4x plus 16. Right, let's see what that looks like. Okay, I didn't change my window or anything yet, so the first thing maybe is that I look at my table and say, okay, where are my values? So it looks like here's my initial height at time 0. This would be the answer to our first question. At time 0, the ball was 16 meters high, so his balcony is at 16 meters high. And then the ball looks like it hits the ground here around 4 seconds, right? So let's make our window big enough to see all that. What's the biggest y value is 18. So we can go into our window, and I'm just going to start at -1. I'm going to go to 6, make sure I have enough time to see everything. The y value, I like to go below the x-axis so that I can use the calculator to see the x-axis. And then a maximum value, let's say 25. That should be more than enough. Let's see if we get this picture. Right, our initial height again was 16, and then the second question says what's the maximum height? So that's going to be our vertex in here somewhere. So let's calculate that. Second calc, and this is option 4 again. It's a maximum. We scroll over until we get to the left side of our vertex. It's okay to give yourself plenty of room around the vertex, just to make sure that you have the vertex in there. Have the calculator guess, and it says the maximum is at 1 second and it's 18 meters high. And then the last one was when will the ball hit the ground? That's going to be the x-intercept, which we called 0. So option 2. We're going to scroll over to our x-intercept, and then we want to be on the left side of the x-intercept first, which is over here. And then we scroll to the right side of our vertex. So I've passed it, so I'm on the right now. Right, and it says it's at 4 seconds. So again, our window we changed around so that we could see everything. The ball, the height of the ball when it was thrown, that's at time 0, which is our y-intercept, which is 16. The maximum height of the ball is the vertex, and we only need the y value for the height, so that's at 18. And when will the ball hit the ground? That's the x-intercept, and we found that that was 4 seconds. All right, try the practice problems. You have an assignment. It'll start on Thursday and won't be due until Monday at 3 o'clock because Friday is a holiday. Have a good weekend.